Heinemann Higher, Chapter 4, the Trigonometry, Graphs and Equations, Exercise 4J at the end, number 2. There's 3 graphs here. You need to write down some information about them, each of them. Period, amplitude, and write down what the actual function is. First one, this one here, starts at the top and goes down, so that's a cos, but first of all it said, what were the 2 things it said first of all? What's the period? Well, somebody asked me. Period, so that's 180. Well, that's a bit easy because it repeats itself at 180. Alright, so the period is 180 degrees. Although, when it comes to writing the function, it's actually the frequency that's more useful than that, which means how many wavelengths do you see by the 360, which of course just means the period into 360. Get it from that. Amplitude. Well, the amplitude is going to be the amount it moves up and down. Now there's a difference of 8. 5 take away negative 3 is 8. So the amplitude will be a half of that. A half of 5 take away negative 3. A half of 8, which is 4. So it's going up and down 4. Going up and down 4 means it should only reach 4. And it's not asked for this part, so by reaching 5, that means it's actually oscillating about a line that's been shifted up 1, and it's going up 4 and down 4 from that, which means that 3 then for the function would be this. It's a cos, because it starts at the top. It's got an amplitude of 4, so it's 4 cos. Its period is 180, so its frequency must be 2. There'd be 2 wavelengths by 360, so it's 4 cos 2x. And then finally it's been shifted up 1. So that would be the first one. B then, another cos graph. But first of all, what's its period? Well, that's easy enough. It repeats itself by 720, so period is 720. But of course when it comes to write the function, it's really the frequency you want to know. How much of a wavelength or how many wavelengths appear by 360. So that means its frequency is actually a half. You'd get that by doing 360 divided by the period, which in this case is going to give you that half. Second bit, amplitude. Well, that's just a normal one. So the amplitude is just 1. And then for the third part, so what is the function? It's a cos. Starts at the top, it's a cos. It goes up and down 1, so it's just 1 cos. It's got a frequency of a half, and it's not shifted up and down or sideways, so that's it. It's just y equals cos a half x. Well, that one was nice and easy. Part C. Now this time, I'm not so sure about the way they've produced this diagram, because they've got this pi upon 2 in the diagram looking as if that's what the upper part tends off to, as if the next part's going to appear from this side, and that's why they've not drawn anything here. Just have to ignore that pi upon 2, the information's in these 2. There's 2 corresponding points on the curve. So that will be 1 period, which means the period goes from 0 to pi upon 4, so the period is actually pi upon 4. Now when it comes to actual frequency though, with the tangent graph, it repeats itself, or it should repeat itself, not every 360, but every 180. So in this case, for the period, so for the frequency rather, the frequency is going to be, it would be 180 divided by the period, or in this case it's going to be pi upon 2 divided by pi upon 4, whichever way you like, multiplying the top and the bottom by 4 and then parts cancel, or you could do pi upon 2 times 4 upon pi, whichever way, that's going to give you a 2. But back to this, amplitude. Amplitude, well, since there's no top or bottom to this, there's no information, there's no extra points given, there's nothing you can do with this. There's no information at all about the amplitude. You need to be given a point because there's no tops and so on. So I can't say what the amplitude is. If I stretched that, it would still just look the same to me. I wouldn't know where it is. So the third part would be this. Well, it's a tangent. So I've got a tangent which may have been multiplied. I can't tell, there's not enough information, but it's got a period of, it's got a frequency of 2, so it's tan 2x, and it's been shifted up 1, but not across the way at all, because it should be centred at the origin. So tan 2x plus 1 is the answer to that.